Alright, welcome back. It's time for lesson 16. What's your favorite math snack? So put your comment below. I like Fritos. Hey, binary-wise, it's time to do a cool thing. Since binary uses powers 2, 2, 4, 8, 16, 32, but 1, power 0. Moved on. We turned all these ones off. That one on there. 16 plus 8 plus, well, not plus 8, not plus 4, not plus 2, not plus 1. 1, 0, 0, 0, 0. Binary solo. 16 power 2. Less 16. Whew. Simplifying and evaluating variable expressions. I left up on the board the answer to the last problem in the last lesson that I did in the video. M squared nx plus m n squared y plus 2m np. And we were saying, well, we didn't know what those letters stood for, so we just kind of left it there. But what if we did? What if somebody told us what m equals n and x and p and y? Why? I don't know why, but what if they did? So I put over here these little sliders. What if we could take this and we had the choices of 1, 2, and 3, and we were like, well, what if m is 3 and n is 2? And what if we change these things around? We'd have lots and lots of different possibilities for the final answer if we multiplied all this stuff and added it all together, right? That's pretty much what we're going to be talking about today. Both evaluating these, that would be plugging in for m, the number 3. Put a 3 right here, square it. Put a 3 right here, multiply by this stuff. Put a 3 right here, and once all those other numbers are in there, getting just one number answer. That is evaluating, taking a variable like m or n or p or x or y, and replacing it with an actual number. Replacing those with the actual number and then seeing what you get. Okay. That's evaluating. Now, simplifying, hang on, let me go get what we're going to do is we're going to start off with just evaluating something with 2 variables, like an a and b or an x and y. And then we're going to move on to 3 variables, and then maybe even what math can we do with the letters to simplify them down before we plug the numbers in. Okay, there's a mantra in mathematics and algebra especially, and that would be simplify, simplify, simplify. Put something in a more usable form or a simpler way of expressing it, probably the most simplest and then most simplest. But there are preferred ways of answering problems and things being simplified. And a lot of kids will say, well, I got that right because I left it as 3 squared, and that's really the answer. It says, yeah, but you didn't finish that off and make it 9 as simplified. So let's get to it, right? Okay. What would happen if this was our case and then we just take the slider and we move it? It's like, what if y is 2? What if x is 1? Plug them in and see what we get. Let's do some evaluating and let's then do some simplifying. Time to start with 2 variables, m and n. Now here's the problem with brackets and negatives and distributive property, bunch of stuff that you could do. And maybe I'll do this one 2 different ways and try to do it quickly here. For me, the best way to do that substituting business, the evaluating problem, is to, every time I got a letter, to put little parentheses. We talked about this before with all the different symbols of inclusion. So in this problem, we're going to have, anytime there's an m, we're going to put in a 5. Anytime there's an n, we're going to put in a 2. So I'm going to make a space for it first, and then I'm going to plug those numbers in, and then we'll do the math. How's that sound? It sounds great. That's what I was thinking. Oops. do what I said I was going to do. I'm going to put parentheses, got the big bracket, I got the negative sign. I'm going to put more parentheses, I'm going to put bigger parentheses, I'm going to put little parentheses, I'm going to put bigger parentheses, I'm going to put a bracket. That's my setup. That's my plan of attack. And now I'm just going to go up here and I'm going to say M. I'm going to put a 5. So 5 goes there, 5 goes there, and anytime I see an N, I'm going to put a 2. And so 2 goes there, and a 2 goes there. If I start using order of operations, I'm going to work from the inside out. So that means I'm going to work in here first, and I got 5 and 2 makes 7. I've got that 2, and really it's a negative 2, and those guys are inside of the big brackets, and I've got this 1 and 5 outside. Let me do this inside first, just to follow the order of operations. Negative 14. I'm going to take away the brackets there and got 5, and that makes 50, 60, 70. Negative 70 for my answer. Step 1, step 2, step 3. Now, I noticed that this has distribution in it. That's multiplication. Maybe there's a different way to do this before I plug the numbers in. So I'm just going to back up here. And remember, you can back up too. You can go back 10 seconds or 15 seconds. But what if I did distribution here and went negative nm, and then I've got a negative n times n, or an n squared. And then I plug those numbers in, because now I got something where maybe that'd be a little quicker. So I've got something, well, let's just do it straight up. 5, and then I've got negative n times m, so that's going to be, let's just do the whole problem in parentheses, 5 times 2, minus n squared, that'd be 2 squared. 2 squared is 4. I've got a negative 10. See, we're going to end up at the same place, right? What did we say? That was negative 70. So I get to the same answer, just in a different way. So there I did a little bit of the math with the letters first before I plugged the numbers in, and still works. Actually, that's probably preferred. That is a better simplification, because we get things like that, which is a better problem than what we had right here. You got a lot of addition, then multiplication, then more multiplication, and here you just play around with the letters. You can do that, and out comes the correct number when you plug it in to evaluate it. So there I'm using both skills. I'm using the simplification. I'm doing some of the math and seeing where that goes, knowing that once I put the letters in, if I've done all that other math right, I should get the same right answer. Now, they could write these things in lots of different ways. They could write these things. Here's one off of the reteaching where they do, they use 3 letters and they throw in a fraction bar and negative and multiplication and a variables and a number. All you need are what those letters are equal to, though this one up here at the top probably could do some stuff. I noticed there's a p in the numerator and a p in the denominator, and those could get canceled out. If I have 7 here, I'm going to have a 7 down there, and 7 divided by 7 is 1. So I can simplify that a little bit. And I noticed there's a q down here and a q up there. I can get rid of those as well, and my problem is just 5r over negative p. I don't even need to know what q is at this point. I need to know what the other 2 are. If that freaks you out to just cancel those things out, equal to 1, you leave that there, but I could have gone 5 PQR over negative PQ. I could have done the distribution there, rearrange stuff, and then plug in whatever P, Q, and R happen to be. Maybe it would be on a slider. Maybe it would be, I don't know, expressed some other way. So honestly, it doesn't matter how many letters there are. There could be 20 letters. As long as you know what each letter, what its value is, you plug it in, and you go from there. So we always start off with, let's start off with 2, make you feel good about that, and then we'll just say, look, it's the same thing if we go to 3 or 4 or 5. when you're doing science classes, physics or physical science, you're going to have formulas with multiple variables, and you're going to have to plug in multiple numbers into those slots and then evaluate those things and see if you can get the right answers. So sometimes there's a little bit of simplification that can happen first. Probably earlier on in things with algebra, students are not as comfortable with playing around with the letters. They want the number. But let's just show you how, these things don't bite. Look at that first when we say, what can we simplify? And I see that we've got the distributive property here, the 2 minus t in the parentheses. So I could restate it, which would be a way of talking about it. I said s times 2 is 2s, and could put the number first and then the variable, and then minus s times t plus s. Wait a second. These are like each other. So I can smush them together using the associative property. 2s, and this is a 1s. 2s plus another s is 3s. And now if you just tell me what s and t are, I can do the math. And this one says if s is negative 4, and if t is 2. So now we got negative 12 minus negative 8, or negative 12 plus 8. Negative's a bigger number here, so I find the difference between them, which is 4, and then it has to be negative, and I've got my answer. Okay, so I did a little bit of simplification. This is simpler than that. Yes? This has multiplication, subtraction, addition. This has, well, multiplication and subtraction. It's fewer pieces to deal with there. If I could just simplify that and boil it down to a smaller problem and then go for it. Now, as I was going along, I was justifying each step that I was doing. I was saying which property I was using. I need to know which tools are in my tool bag to solve this problem, and I need to apply them honestly. Can't apply them when they don't apply. Not everything is a nail, okay? So you can't use a hammer for everything. But going through that thought process, where can this get simplified? Maybe it won't simplify it and you go back to the original, but you haven't broken anything. So might as well just try it. Might as well just try it. What's the worst thing you could do is get it wrong and then have to learn something from your mistakes? That's no problem. I make mistakes all the time. If you watch enough of my videos, you'll find them. And don't burn my house down, right? It's okay. So there we go. There's evaluating, simplifying, or both with these variable expressions with letters in there. Once we know what those letters stand for, we can plug them in at any point that we want to. And if we're following the rules of math the right way, we should get the right answer. Good luck.